This is going to be your first flipped video classroom for the algebra class. We're going to be talking about fraction buses, which is what you guys requested earlier today. And what I think would be a good idea is I'll put a problem up on the board, and if you think you can do it, go ahead and press pause, and then try and work it out, and then I'll work it out and see how close you are to getting it right. And we can do that for each of the problems. So as I put it up, if you think you want to try it without me, just press pause, and then you can go ahead and do the problem. So the problem that we have here on the left-hand column is 2x plus 7 equals 12. Excuse me, 2/5 x plus 7 equals 12. And then I rewrote it here in the middle, 2/5 x plus 7 equals 12. All right. And so the very first thing I think of when I look at this is, what don't I like? Or what makes it hard? Those are the two questions you hear me ask a lot. What makes it hard? And the most common answer to that is the fraction. And I disagree with that. I don't think it's the fraction, because all of these are fractions. This is the fraction 7 over 1. And that's the fraction 12 over 1. So if it were just a fraction, that means all of these would be hard. Yet, obviously, these are not the parts that we're worried about. So it's not that it's a fraction, it's that our denominator is not 1. So the hard part about it is denominator doesn't equal 1. Does not equal 1. And if it did equal 1, it'd be a lot easier. So that's what we're going to try to do. We're going to try and get rid of that denominator so that it equals 1. That should get rid of that 5. So, as we know, the way that we do this is we put parentheses around the whole thing. So I put parentheses around the whole thing like that. And I'm looking for a number to put on the outside that when I multiply and do the distributive property, it's going to get rid of that 5. So the easiest way to look at that is this number right here is what I want to get rid of. I multiply by what I want to get rid of. So I'm multiplying by 5 over 1. And then I do the distributive property to each of these, everything on the inside. So then this is multiplied by 5, and this is multiplied by 5. And of course it's over 1. So then when I do that, this right here makes a giant 1. Those simplify out and I get a giant 1. So I'm left just with 2x. And here I have 35. And here I have 60. And now I've set up a relatively simple two-step equation. Subtract 35 from both sides. Whoops. Not 53, 35. And I'm left with 2x equals 25. And then my last step is to divide by 2. So x equals 25 over 2 is fine. Okay? So there's the solution for your first one. I'm going to go ahead and put up another problem. Again, press pause and see if you can calculate it out without me. And if you can, awesome. If you can't, then no worries. We'll keep working on it. Okay, so this one, 1/4 x minus 5 equals 2/5. Okay, and just like the last time, I go ahead and press pause if you think you're ready. And if you are not quite ready, then no worries, I'll do it. So again, what makes this hard, or what don't I like about it? I don't like that I have a number other than 1 on my denominator. I don't like the 4 and I don't like that 5. So I'm going to multiply to get rid of it. But this time, where up there I only had the 1 denominator to worry about, I have to worry about both these denominators. So I'm going to multiply by a number that will get rid of both of those denominators. And the best number for me to multiply by, of course, would be 20. That's 20 over 1. And then I distribute. Doesn't matter if I put the 20 in the front here or the back here. Either side works. I do want to note, though, that I'm not multiplying the 20 by the x. I'm multiplying the 20 by the coefficient of 1/4. So that's a 20 there. That's a 20 there. 20 over 1, 20 over 1. And then what we have here is this. It's going to simplify out to where this becomes a 1 here, and that's a 4, which is exactly what I wanted. This, of course, is nothing simplifies, and this simplifies out to where that becomes a 1 and that becomes a 5. You'll notice that that is the opposite coefficient, that makes sense. So then what I end up with is 5x, because 5 times x equals 5x, minus 100, 20 times 5 is 100, equals 2 times 4, which is 8. And then add 100 to both sides. End up with 5x is equal to 108. And the last step will be to divide by 5. And I have with x equals 108 over 5 is a perfectly acceptable answer. Okay, so there's our second problem. And it was a little bit more difficult than the first one because we had two denominators that we were trying to make a 1 out of. And it wasn't any big deal. I just multiplied by a different coefficient on the outside, or different number on the outside. Okay, I'm going to go ahead and put up the third problem. You have to excuse me while I erase here real quick. And you'll see each one gets a little bit more difficult, and we'll attack them one at a time. So the third problem that we have is 1/2 plus 3/4 x equals 2/3. 1/2 plus 3/4 x equals 2/3. Okay. So you probably can tell, to answer my questions, what makes this difficult. Well, the reason this one's a little bit more difficult than the last ones is that we now have 3 denominators that we need to get rid of or turn into 1. And so I'm going to do it the same way that I was doing them before. I'm going to multiply, so I use parentheses like this, showing that I'm multiplying everything, not just the left side, not just the right side, but the whole thing. And now I'm looking for a number that I can multiply that will get rid of both 2, 4, and 3. So I look, 2 times 4 is 8, but 3 doesn't go into 8. 3 times 4 is 12, and 2 goes into 12, so 12 would be a good number. So again, I'm just finding a common denominator. It doesn't have to be the lowest common denominator. It's easier if it is, but it doesn't have to be. So I'm going to multiply by 12, and again, distribute in here to each one of these. So then this is a 12 here, 12 over 1, and this is a 12 as well, 12 over 1. Okay, and just like last time, I'm now going to find my ones. And I see that this 2 can go into 12, which I hoped it would. 2 goes into 12 6 times. That works out. And 4 goes into 12 3 times. And 3 goes into 12 4 times. Notice that every time my denominator goes into the number that I'm multiplying by. That's the whole point of doing this. I want to make that denominator a 1. Make that denominator a 1. And now I can just multiply. 6 times 1 gives me 6. 3 times 3x gives me 9x. And 4 times 2 gives me 8. And then I'm back to my two-step equation. So my next step would be subtract 6 from both sides. I get 9x equals 2. And of course my last step is to divide by 9. X equals 2/9. Okay, hopefully you got that right. Alright, the next one we're going to do is a little bit different. It's going to be a diamond problem that has fractions in it. I know that this was another interest that several people had, was how do we do diamond problems with fractions. So I'm going to go ahead and do it because we can use fraction busters to solve that one as well. So it looks something like this. Negative 2/9 and 10. Negative 2/9 and 10. And what I'm going to suggest you do first is to, let me back up a second. What we don't know is what this number is. And anytime we don't know something in algebra, we always put in a variable. So I'm going to put in x. That helps tremendously. Now I can write an equation. And the equation I'm going to write is what I do with this number and this number to get this number. And as you recall, the wings here, these two numbers, I multiply to get my top number. So then I can say negative 2/9 x equals 10. And you see that we now have a fraction. And anytime we have a fraction, we can use fraction busters. So I'm going to put parentheses around the whole thing. What do I want to get rid of, or what don't I like? I don't like the 9. I'd like to get rid of that. So I could do that by multiplying by 9 over 1. And over here as well, by 9 over 1. So the whole point for doing that is that these would then simplify out and become a 1. So I'm left with negative 2x equals, and then over here it's just 90, like that. And my last step for this one would be to divide by negative 2 and divide by negative 2. So then these simplify out, and I'm left with x equals 45. Okay, so x is equal to 45, but that's not this number. Okay, that's not this number here, so that's the side number. So now what I have then is I have this. I have negative 2 ninths and 10, and over here I have, excuse me, that would be negative 45, not 45. Negative 45. I have negative 45. Alright? Now, to get this bottom number, we're going to put in another variable of y. So, negative 2 ninths, and then to get the bottom number, we add these two, at plus negative 45 is equal to y. Now, when I'm adding two numbers with to have the same sign, from adding a fraction and a whole number with the same sign, I simply put them together. So then my answer would be y equals negative 45 and 2 ninths. Okay, so there are several different problems. This would be the most challenging one that I could give you. It has fractions in all three terms. It doesn't matter. Just multiply by a number that gets rid of all your fractions, and then from there it's a two-step equation. So these are your first notes. Like I mentioned, go ahead and explain to yourself in your blue column exactly what we did for each of the problems that we had here. And then if you have further questions, you can ask me tomorrow. All right, see you guys tomorrow. Bye-bye.